Evolution is a complex interaction of various processes, but we can simplify it a bit if we break it down. We can summarize the separate processes quite simply. We'll start at the top. All organisms have descended into different lineages from common ancestors, or in other words, every organism has developed into its own current family line from other organisms that existed in the past. So, we can trace all living species back through time to a few common ancestors. Let me put a simple diagram on the board. We start at the top with organism A. From organism A we get organism B. So, I put B here below A and draw a line down from A to B. Then, over time, B undergoes changes leading to organism C, and so on. Notice I said B undergoes changes. What kind of changes might that include? Well, evolution includes processes such as genetic drift, natural selection, adaptation, interbreeding, and extinction. Probably you're most familiar with extinction, especially the extinction of dinosaurs. Anyway, today I will focus my talk on genetic drift. We'll keep it simple and just focus on that one idea for now. In order to talk about genetic drift, I'll need to use some terms specifically related to genetics. I'll try to define each term as we go so that nobody gets lost, okay? The first term I'm going to throw at you is alleles. What are alleles? Maybe before that, how do you spell it? It's A-L-L-E-L-E-S. So what are they? I assume you know what genes are, right? Well, alleles are different versions of the same gene, and they can encode different information. For example, take the case of eye color. The gene for eye color has many different alleles, and each allele contributing to a different eye color. But in terms of genetic drift, alleles are special because they are related to genes formed by mutation. That's another term we'll need to use in this course. Mutation just means change. It could be a good change or a bad change. So, alleles are gene codes that could have some kind of mutation compared to gene codes from ancestors. Some of you might be thinking, wait a minute, a bad mutation. In evolution, things are supposed to evolve to fit into their environment better. So how can mutated alleles be bad? Remember, there are different kinds of evolutionary processes. Good changes to fit the environment usually occur through natural selection and adaptation. But I'm talking about genetic drift. This incorporates random genetic changes. If enough members of a population include these mutated alleles, then evolutionary change can occur. The proportion of members with these alleles can rise over time to become the majority of the population. Given enough time, the mutated alleles can totally dominate. The original ancestors' genes are replaced by the new alleles. Evolutionary change has occurred. A key point about genetic drift is that the process is random. I mentioned that before, but another key point is that genetic drift involves neutral alleles. You can think of neutral in this case meaning neither good nor bad. It doesn't help the organism, nor does it hurt the organism. Something like eye color would be neutral for most organisms. Evolutionary change that leads to more blue-eyed members of a population can be accounted for by genetic drift.